Hi guys, so in today's video we're going to be taking a look at indefinite integrals. As we've previously seen, indefinite integrals are simply a new terminology for antiderivatives. The notation for an indefinite integral is just an integration problem without the limits of integration. And the answer is written as capital F of x plus c, where f of x represents the antiderivative function, and where c is called the constant of integration. Capital F of x is also known as a primitive function. We'll quickly remind ourselves of some of our simple antiderivatives. The indefinite integral of x to the power of n is x to the power of n plus 1 divided by n plus 1 plus c. The integral of e to the x dx equals e to the x plus c. The integral of cos x dx equals sin x plus c. The integral of sin x dx equals negative cos x plus c. And the integral of 1 on cos squared x dx equals tan x plus c. A really important one to remember is that if you have the indefinite integral of a function of kx, the answer is the antiderivative function of kx divided by k plus c. Let's look at a couple of examples of that. So the indefinite integral of e to the 3x dx is just e to the 3x divided by 3 plus c. And the indefinite integral of cos negative 2x dx is just going to be negative sine of negative 2x divided by 2 plus c. We can expand this last one to look at what would happen if we have chain rule functions of a more general nature. So if we're trying to find the indefinite integral, and what you recognize is you've got two functions multiplying. One which is a function of another function, so it could be that you've got some polynomial inside brackets to the power of n, and you recognize that the other function is the derivative of the inside function. So you've got g dash x and f of g of x. What that means then is that you've got the antiderivative function of f of g of x plus c. I'll give you an example of this. So here we've got the indefinite integral of 6x multiplied by e to the power of 3x squared dx. And we recognize that 6x is the derivative of 3x squared. So essentially what our answer is just e to the power of 3x squared plus c. The reason for this is we know going in the opposite direction is differentiation. If we take e to the power of 3x squared plus c, we know the constant disappears. That's why we get this constant of integration in the first place. It recognizes that we could have had any number there added as a constant and it would not have shown up in our differentiation. So the differentiation of e to the power of 3x squared is going to be e to the power of 3x squared multiplied by the derivative of 3x squared. So we're going to end up with 6x times e to the power of 3x squared, which is our original function. And that, of course, is our definition of taking an indefinite integral. We need to find a function that could have been differentiated to give our original function. Some functions may look more difficult to integrate, but sometimes we can recognize them simply as the result of using more complex rules like the product or quotient rules. So for example, the indefinite integral of 1 plus x times e to the x is recognized as the derivative of xe to the x, because the product rule gives us two terms, one where we have differentiated x to get 1 times e to the power of x, and where we've differentiated e to the x to get x times e to the power of x. The idea here is that some difficult looking problems with indefinite integrals can sometimes be quite simply solved by recognizing them as the result of certain rules that we've learned to use. Finally, we can remind ourselves that indefinite integrals follow the same rules as definite integrals, except that we don't have the limits. So the integral of k times a function f of x is simply k times the antiderivative, capital F of x plus c. In the same way, the indefinite integral of the sum of two functions is just the sum of the two individual integrals, which gives us capital F of x plus capital G of x plus c.